Today we're going to learn about periodic functions that model periodic behavior. This is an example of a periodic function because it has a section that repeats exactly, well, the whole thing. So this part is going to repeat again, and then it's going to repeat again, and so on. It's just the same thing over and over and over again. Periodic functions have a maximum point and they have a minimum point. We can also talk about the length of one cycle. So from there to there, this is the part that repeats. We call that a cycle. And the length of that cycle is called the period. The period of this particular function is 5. So you can see it goes from 0 to 5, and then it's going to start over again, and it's going to go from 0 to 5 again. Now, you can choose a different starting point if you want to. If you wanted to say it starts right there, and then it starts over again, it would start over again right there, and that would be 1, 2, 3, 4. That'd still be 5 units long. We also talk about the amplitude, and the amplitude is half of the distance between the maximum and the minimum. So here, my maximum is 7 and the minimum is 1. So the distance between the maximum and the minimum is 7 minus 1. That's 6. Now if we take that and we divide that by 2, we get 3. That is called the amplitude. Here's another example of a periodic function, and you can look at this and you can decide where you think you recognize the part that repeats. So I'm going to say, I think right now that this looks like the part that repeats. And then, okay, there's another one over here, and so on. So my maximum for this function, my max is 4. My minimum is 3. The length of one cycle, we call that the period, is, we're going to say it starts here and it goes to here. So this scale, every square is 2. This is 2. So this is going 2, 4, 6. So the period of this function is 6. We can figure out the amplitude by taking the maximum, whoopsies, my minimum I just noticed was -3. I made a mistake there. The amplitude is 4 minus -3 divided by 2. So that is a distance of 7 divided by 2. Also, I should mention that the amplitude is always a positive number. It's a distance from the middle of the function. So this is an okay answer. You could put this as an exact decimal, but we usually leave it as a fraction in lowest terms. The middle of this function is right here. If this is, the top is 4 and the bottom is -3, the middle, to find the middle, you just take the average of 4 plus -3. It's like you're finding your axis of symmetry and dividing it by 2. So that is equal to 1 over 2. That's the middle. Now 1 over 2 would be about right there. And we call that the equation of the axis. And in this particular case, this would be y equals 1/2. When a graph is exactly repeated over and over again, it's called a periodic graph. The first three are examples of periodic functions. This last one, because it's not repeating exactly, in this case it's getting smaller, the amplitude is getting smaller each time. So this one is not a periodic function. Let's just recall the definitions that I already explained to you. So a cycle is one complete pattern of a periodic function. And you can identify it anywhere, whatever part you want to say repeats. So I'm going to say that it starts right here, it goes up and comes back down. And I'm going to say that that is one cycle. The period is the horizontal length of that cycle. So in this particular example, the period starts at 2, I say, and it goes to 6. So the period would be 4. The amplitude is half the distance between the maximum and the minimum. My maximum here is at 9, and the minimum is at 3. So to get the amplitude, to find the distance between them, you subtract them, and then you would divide that by 2. So this is 6 divided by 2. This is equal to an amplitude of 3. To get the equation of the axis again, remember, is the middle of the curve, vertical middle, and you would take the maximum plus the minimum, it's like we're finding the average, and dividing that by 2. So this is 12 divided by 2. The middle is 6. That means the equation of the axis is y equals 6. And that would be right here, if I was to draw a little dotted line through the middle, that would be my axis. What I'd like you to do now is try and find the minimum, the maximum, the period, and the amplitude of these three functions. So pause this video now, try that, and then check your answers. For the first one, my minimum is at 2. My maximum is at 8. The period, I'm going to say it starts here, goes up, down, and then it's going to start all over again. So the period is 5, and the amplitude is, I got to take 8 minus 2 divided by 2. That would be 6 divided by 2, so that would be an amplitude of 3. For the next one, my maximum is at 9. My minimum is at 2. My period, I'm going to say that this is a cycle, starts right there, goes up, and then it starts to go back down again. So the period is equal to 8, and the amplitude is 9 minus 2 divided by 2. That would be 7 divided by 2. This next one, my maximum is 8. The minimum is 4. One cycle, I am going to say, is 5. So that would give me a period of 5. And the amplitude is the max minus the min divided by 2. That would be 4 divided by 2. So that would be 2. Now let's look at an application. The elevator of an apartment building is broken. It starts on the 5th floor and goes to the basement and back up again, but never stops on any floor. It continues to move between the floors, taking 2 seconds between each floor. So we're first of all going to graph the motion of the elevator. And it starts on the 5th floor, and it says it takes 2 seconds to go between each floor. So it's got to go 6 floors if it goes down to the basement. So 6 times 2 would be 12. So it's going to start at 5, and it's going to go in 12 seconds down to the basement. And then in another 12 seconds, it's going to go back up to the 5th floor, in another 12 seconds down to the basement, in another 12 seconds up to the 5th floor, and so on. So it goes down, up, down, up, down, and that would continue going on forever. The period of the motion is the length of one cycle. So this, I'm going to say my cycle starts right there and ends right there, and that is 24 seconds. How long would it take to make 20 cycles? So we would just have 20 times 24. That would give us 480 seconds. At what floor will the elevator be on after 1 hour? So after exactly 1 hour, where's the elevator going to be? Well, 1 hour is 60 minutes, but we have to do this in seconds. So 60 minutes times 60 seconds, that would give us 3,600 seconds. One whole cycle is 24 seconds. So if we divide this by 24 seconds, we get exactly 150. That means then that there are exactly 150 cycles. So that means that the elevator is going to end up back at the top, which is the 5th floor.